Hello everyone. In this video, we'll revise order pair. So, as we have already discussed these things in our classes, I'll be explaining them in short. So, before starting order pair, we need to know about the terms like set and pair and ordered. So, first of all, let us discuss what is set. Set means the collection of well-defined object. We know that already. So, pair means set of any two elements or set of any two objects. That is called pair. And or we can define pair as the arrangement of any two objects or numbers or elements. For example, pair of shoes, pair of globes, and pair of the elements like a comma b, and it can be enclosed within small bracket. As we have already said that pair means set of any two elements. So here 2 comma 5, it's a set of two elements. We can say it as a pair because there are two elements. And 5 comma 2, that is also the set of two elements. That's why it's a pair. So what things is required to be a order pair? Yes, ordered means it must be in a fixed order. So we can define an order pair as a pair of elements arranged in a fixed order. That is called order pair, we can write. Or if you want to write long definition of order pair, you can write a pair of elements arranged in a fixed order, separated by comma and enclosed with small brackets. Small brackets are also called parentheses, is called an order pair. So here the example, a comma b enclosed with small bracket. Similarly, ram comma sita enclosed with small bracket, book comma pen enclosed with small bracket, and so on. So these are some examples of ordered pair. So in order pair, the first uh, component of the order pair is called antecedent, and the second component is called consequent, and it is also called the x coordinate, and it is also called the y coordinate in terms of coordinate axes. All right, so we'll be discussing about that later on. uh, to be a order equal order pair, so we can say when two order pairs are said to be equal. So the concept or the theory goes like this: two order pairs are said to be equal if and only if their corresponding elements are equal. So if x comma y equals to a comma b, then it must hold that x must be equals to a and y must equals to b. So for example, here 2 comma 5 is not equals to 5 comma 2, which can be clear from the graph given below. So here is the graph. So 2 comma 5 lies here and 5 comma 2 lies over here. See, they are totally two different points. So by this also example also we can clearly understand that two order pairs are said to be equal if and only if this if and only if can be written as IFF in short form. All right, so these corresponding elements must be same. That is, first component or antecedent must be equal to each other and consequent must be equal with each other. Only then they can be said as equal order pair. Uh, so let us discuss about the problems related with order pairs now. So let us consider these examples. We'll be solving these two examples over here. So here the question is, find the values of x and y from the following. So these are the two equal order pairs and we need to find the values of x and y. Since x comma minus 2 is equal to 4 comma y, so at first equating the corresponding elements, we get x equals to 4 and minus 2 equals to y. But basically what we do is that we write the variables in the left hand side always and constant to the right hand side. So I have written x equals to 4 over here and y is the variable. Although it's minus 2 equals to y, we will write y equals to minus 2. We can find the values directly in such cases. No need to do any simplification here. Answer comes directly. But in this case, in b number, you can see the 3 comma 3x comma 4 is equals to 6 comma 2y. So in this case, so we equate the corresponding elements. What we get, 3x equals to 6 and 4 equals to 2y. But what we will do is that we will keep the variable terms having variable in the left hand side. So 3x equals to 6, we consider this as equation 1, and 2y equals to 4, we consider as this equation 2. So from equation 1 we get 3x equals to 6, so x equals to this 6, 3 is in multiplication, so it comes in division in the right hand side. So 3 times 2 is 6, therefore the value of x is 2. Similarly, from equation 2, 2y equals to 4, so 2 is in multiplication in left side, so it goes in divide in right hand side. So 2 times 2 is 4, therefore the value of y is 2. Similar, in this way we can calculate the values of x and y. So let me go with two more examples. So here 2x minus 1 comma y plus 2 equals to minus 1 comma 2. So equating the corresponding elements, what we will get? 2x minus 1 equals to minus 1 and y plus 2 equals to 2. Alright, so what we get? We get two equations over here. So variable, we have kept that in left hand side. 2x minus 1 equals to minus 1 and y plus 2 equals to 2. So from equation 1, what we get? 2x minus 1 equals to minus 1. We need to shift this constant of minus 1 to the right hand side, and its sign gets changed. It becomes plus 1, minus 1 and plus 1 0, and 0 over here is 2x, isn't it? So it comes in division. So 0 upon 2 is 0. So value of x is 0. Similarly, from equation 2, what we get? Y plus 2 equals to 2. Shifting this plus 2 to the right hand side, it becomes negative 2. 2 minus 2 is 0. So the value of y is 0. Hence, what we got? The value of x and y both are 0 in this case. Similarly, we can discuss this example. 2x plus 4 comma y plus 5 equals to 3x plus 3 comma 6. So here this first term and first term, they are equal, and second term, they are equal because they are equal order pairs. So equating the corresponding elements, what we get? We can write it directly. You can write here also, equating the corresponding elements, we get 2x plus 4 equals to 3x plus 3. So 2x plus 4 equals to 3x plus 3. It's equation 1, and y plus 5 equals to 6. It's equation 2. So solving equation 1, here you just see it carefully. This type of equations you have solved in class 7 already, but anyway, let us repeat it once again. So here 2 is with the variable x, and 3 is also having a variable x. So 3 is greater number, that's why I'm shifting this 2x to the right hand side. See, it becomes negative 2x. Whenever we shift the term to the right hand side, we change its sign. Similarly, 4 is in left hand side, and this plus 3, which was in right hand side, we have taken to the left hand side, and its sign gets changed. So 4 minus 3 is 1. So 3x minus 2x, 3 apples minus 2 apples means only 1 apple. We don't write that 1. Alright, so x equals to 1. So this is the value of x. Similarly, solving this second equation, y plus 5 equals to 6. It's very easy. Y plus 5 equals to 6. So 6 is in right hand side. We need the variable value of variable y. So shifting this plus 5 to the right hand side, it becomes negative of 5, and y 6 minus 5 is 1. Y equals to 1. In this way, we can find the value of x and y. Now let us discuss another model. So here the question is x plus y comma x minus y equals to 5 comma 3. Since this order pair are equal, so equating the corresponding elements, what we get? X plus y equals to 5 and x minus y equals to 3. So we get two equations. Alright, we can solve this in different way, but I'm using this method here. So adding these two equations, because there is positive y and negative y here, so they can be cancelled out. That's why I'm adding these two equations, first and second. We get x plus y equals to 5 and x minus y equals to 3. So when we add, this plus y and minus y gets cancelled. So x plus x is 2x and 5 plus 3 is 8. So 2x equals to 8, and x equals to 8 upon 2 means 4. So we get the value of x is 4 over here. So replacing the value of x, we can put the value of x in any equation, either in equation first or equation second. So let us put the value of x in equation 1. We get, so x, value of x is 4. So 4 plus y equals to 5. So whenever we transfer this 4 to the right hand side, yes, so it becomes negative 4. So 5 minus 4 is 1. The value of y is also 1, and value of x is 4. This is another example. Now let us discuss another model. So the question is 2 to the power x comma 81 equals to 32 comma 3 to the power y. So solution here, these two are equal order pairs. So equating the corresponding elements, what we get? So first term is equals to the first term, and second term of first order pair is equal to the second term of the second order pair. So what we get? 2 to the power x equals to 32, and it's equation 1, and 3 to the power y equals to 81. I have already told you that we can write 81 equals to 3 to the power y, but basically it's easy to write the variable in the left hand side. That's why I'm doing like this. Ultimately they are equal. We can write 3 to the power y equals to 81, or 81 equals to 3 to the power y. It's same. So from equation 1, what we get? 2 to the power x equals to 32. So now you have to make 32 in the base of 2. So what we get is that 2 to the power 5 equals to 32. You can just find the factor of 32 like this: 2 times 16, 2 times 8, 2 times 4, 2 times 2, 1, 2, 3, 4, 5. So 2 to the power 5 is 32. So equating, the base are same here, so the power must be same. So x equals to 5. We got it. So similarly, 3 to the power y equals to 81. So similarly, find the factor of 81 like this. So 3 to the power y equals to 3 to the power 4 means 81. So base is same. So equating the power, we get y equals to 4. So this is another type of example of order pair.